All right, here's another type of problem that we can solve with just the simple tools that we have so far. Hopefully, it's encouraging that you can solve so many different kinds of problems just with a couple of equations and a little bit of thinking about it. This one is a racing type question or situation, I should say, since nature does not pose questions. Car A begins the race. Now, this is an interesting race. It doesn't start from a standstill. The cars cross a starting line at the same time, but they have different initial conditions to their motion. Car A begins the race with an initial velocity of 10 meters per second. It will accelerate at plus 3.5 meters per second squared for the duration of the race. Car B begins the race with an initial velocity of 3 meters per second, much slower. It crosses the starting line much slower, but again at the exact same time as car A. However, car B will accelerate at a significantly higher rate, plus 5 meters per second squared, for the duration of the race. The race is defined to be 200 meters long. Who wins? And how far ahead is the winner? Well, the questions, as usual, are posed in the order that they should be answered. And if in order to find a winner, we need to know who goes 200 meters faster. Well, if we write what is becoming old hat at this point, is that the phrase? I think so. If we write this, it's always good to check, can I solve this? Am I down to just one variable unknown? In which case, I can solve it. Okay, I have distance, 200 meters. I want to know how long does each car take to go 200 meters under a constant acceleration? Well, it's a similar question to what we've been asking previously, just jumbled around. I have this, I have the initial velocities. I was given those. It was 10 for car A and 3 for car B. I don't have time. That's what I'm interested in. The one that takes the least amount of time to get to the 200 meters is the winner. And of course, I have the accelerations also given in the problem. So let's try. Here is car A. All right, let's plug in. 200 meters equals, we have VI is for car A is 10 meters per second. I'll put the units so that you can follow along. Times T, we don't know T, plus 1/2 times the acceleration for car A is 3.5, and that comes positive because it's speeding up the whole race. Meters per second squared times t squared. Solve for t. Now you can't do this directly algebraically. You're solving a quadratic equation. I'm not going to drag out the quadratic formula for you because, I mean, you've probably been spanked enough times by that in your life, maybe for real. And so I'll show you what we get to do, what dang millennials get to do to solve something like that. And I'll even reposition or rezoom the camera a little bit. So we go into the calculator. And let's see. Can I put it up here? Yeah, let's do that. Can you see what's on the screen there? You can, can't you? So you see I've pre-entered it. And you've got solve. 200 equals 10x. I'm calling t Okay, I'm calling tx just because that's how you enter it into the calculator. 10x plus 1 half, right, 0.5, 1 half times 3.5, that's 1 half a, t squared, right, x squared. I tell it the variable is x, and solve. Now, we expect to get two answers. Again, because the shape of the graph is like this, and we're saying, give me the value, the time value, where this parabolic arc crosses a horizontal line at distance 200 meters. Remember, we've been looking at dt graphs. Well, a horizontal line is going to cross in two places. In this case, we get x, which remember is our t, time value, of one of the solutions is minus 13.92 seconds. We're going to throw that answer away because we're not interested in negative time results. And if I scroll over, I get here, or x equals 8.2, we'll call it 8.21 seconds. And we'll write that down as our answer. Let me zoom us back out here. Okay. We get t equals 8.21 seconds. Now we need to repeat for car B. We get 200 meters equals, now this one started at 3 meters per second times t plus 1 half, but a bigger acceleration, 5 meters per second squared, times t squared. That gives us t equals, again, following the same procedure as before. If you're interested in actually solving that the old-fashioned way, you're welcome to look up how to solve a quadratic equation, the quadratic formula, and plug that all in and get it. But the same way, this gives you the answer, t equals 8.36 seconds. So car A is the winner. Because it got to the finish a little bit more than 1/10 of a second sooner. Now the second question is, how far ahead is the winner at the time that the winner crosses the line, of course, crosses the finish line. So what this question, in order to solve this problem, you have to sort of redefine the question. How far ahead is the winner is directly related to how far has the loser gone. It's the length of the race minus how far has the loser gone in the time it took the winner to win. Hopefully that makes sense. So if we want to know how far the loser has gone, then for car B, when car A has won, D equals, now we have car B's initial is 3 meters per second And what do we use for the time? The time is how long it took car A to win, which is 8.21 seconds. Just a little bit less, right, than B's 8.36 seconds. Plus 1/2 A, car B's acceleration is 5 meters per second squared, and the T is 8.21 seconds. And we don't forget to square that, the 8.21. Okay, we solve, and we get 193.14 meters. Now, we have to be careful to answer the question we're asked. How far ahead is the winner? Well, the loser has gone 193.14 meters out of the 200-meter race at the time that car A won. 200 meters less 193.14 meters equals 6.86 meters. Car A won by 6.86 meters.